Hello, James Flaten here from the Minnesota Space Grant with a high-power rocketry instructional video talking about making ejection charges and also doing ground tests of ejection charges, especially to make sure that you can break the shear pins of certain sections of your rocket. So the first thing I'm going to do is I'm going to put on safety goggles. Just as as good practice. When you are building ejection charges or handling gunpowder, it's a good idea to have safety goggles on. First of all, let me tell you what I'm talking about. First of all, here is an ejection charge. Basically, this is called an E-match. It's got a rather long wire, two of them, and I have them twisted together so that I don't ever have any electricity heading for the business end. And on the business end, the little flag says 1.0 grams, a little bit hard to read, but and I see black tape. And the E-match itself is underneath there. And the reason this is a little bit of a bulb is because there's gunpowder, black powder. And I have it wrapped in black tape. And before it was wrapped in black tape, it was actually put into the end of a glove. So here's the glove. And notice that I've cut a finger off the glove. So let me show you the steps for making ejection charge just like that. And that was a 1.0 gram ejection charge. So first of all, well, you need some black powder. So here it is. This happens to be FFFFG, very fine, black powder. One can also use Pyrodex, which is a black powder substitute. And then you need some way to measure it. So if I'm trying to measure grams or fractions of grams, I could have a scale, although I don't actually use a scale very often anymore. And the reason is it's much faster to have a graduated cylinder. So it turns out that Aerotech motors in particular send their powder in graduated cylinders, and if you hold on to the graduated cylinders, you'll have a very easy way to measure. So in this particular case, what I've done is I put tick marks at the half gram, 1 gram, 1.5 gram, 2 gram level, and then there are, well, if you look very closely, you can see that there are intermediate tick marks, allowing me to pretty easily pour in powder up to a tenth of a gram, 1.1 grams, 1.2 grams, and that's close enough. So you don't need you need a scale that measures at least to the tenth of a gram. And frankly, it would be nice to be able to do 1.12 grams, but in fact, it's not that necessary. So I need black powder. I need E-matches. What do E-matches look like? Well, they come in different shapes, but these are the ones that I use. And so notice that, first of all, the wire is all coiled up, and I want that to be long. And then this end of the E-match is the two protruding wires. So the very first thing I'm going to do is I'm going to twist those together. Just keep the E-match shorted so that no electricity can go to the other end. And then the other end is covered. So this is basically for transportation. Don't forget to take that off. If you just pull on this, unfortunately, it will stay kind of coiled up. So here's a trick that I learned recently. Take a pen or a screwdriver, stick it up the coil, and then just pull. And when you pull, it actually essentially comes almost completely unwound. So none of that coiled up kinky stuff. Here we go. Now this is the business end, and what I'm going to do is I'm going to slide off the cover, and now I can see the E-match itself. That's the part that sparks when I apply electricity, and I need to take that cover all the way off, throw it away, and then originally this end was covered with some insulation, so I'm going to throw that away also. Ultimately, I'm going to take this E-match, I'm going to take some black powder, so here is about 1.5 grams approximately. I'm going to pour it into I won't do this, I'm just telling you what I would normally do. I would pour it into a glove finger. I would place the E-match into the glove finger with the powder. There's no powder in there right now. And then I would use electrical tape to hold it so that the powder is touching the E-match all the time, okay? No matter which orientation. So ultimately, when all is said and done, it looks like that, the original one I showed you. And my recommendation is that you label it with what it is. And the reason is you can't weigh it anymore and tell. And the reason is There's so much tape on there that a 2 gram charge or 1 gram charge might actually weigh the same depending on how much tape you put on there. So this is really the only way to remember what you've got. If you're only making one or two for yourself, that's fine. You maybe don't need the labels, but I often make, a bunch of these up for many rockets at the same time. I'm a professor, I teach classes, I fire rockets off with many students at the same time, and so I need to label them, otherwise we will forget which E-match is which. Ultimately, one would take that E-match and put it onto an avionics bay. So here's an avionics bay, and on the end of an avionics bay, at this end, for instance, there's a cup, and the cup is only a place that I like to use to hold onto the ejection charge. At the other end of the same avionics bay, I already have an ejection charge. This one also says 1.0 grams. So what it is it's attached to a terminal block, and then the other end of the terminal block goes to the electronics on the inside. And notice that this has been cut rather short. These have been separated so that one wire can go to one side, one wire can go to the other side. Make sure that everything is turned off. No electricity in here, please, at this moment. And then what I would do is I would just set the E-match inside the cup, and then I would pull out a piece of tape. I'm using electrical tape, and I would just tape it down. Just trying to keep it there, even when it's this way in the rocket, or this way in the rocket, or the rocket accelerates, or whatever happens. I want the E-match to stay close to this plate. I don't want it to be flapping around. I certainly don't want it to come disconnected. So this is approximately what it would look like inside one of my rockets. That could potentially be the charge for the main, which would typically be above the avionics bay, or perhaps the charge for the drogue, which would typically be below. Remember, of course, you have a motor, and the motor has an eject. So very typically, if you have avionics, I would suggest putting in a drogue charge also, having that fire when the avionics notice that you are at apogee, and then having the motor go off, maybe even intentionally slightly late to back you up. And then again, 1 gram, maybe that's sufficient. Hopefully that's sufficient. And then the motor, 1.3 grams, 1.5 grams would be bigger and serve as a backup. If 1 gram didn't work, then an even bigger explosion is appropriate. So in many of my dual deploy rockets or my students' rockets, they would have an av bay, they would have a charge below to fire at apogee, they would have a motor eject to back them up, and then they would have one, not two, but only one charge to fire for the main. And hopefully that works. Okay, now let's talk a little bit about testing. So let's say that this is the main side. And let's say that I have, well, let me grab a rocket here. Okay, so here's a rocket. It's a dual deploy rocket. And there's the nose cone. And here is the avionics bay. So the idea is when this rocket is in flight, there will be an explosive down here, two, in fact, one from the avionics, one from the motor, that fire one after another. One way or another, I'm going to get this part open and get this drogue out. This is important, of course. And then here's the main. Now, the main typically, the main would be packed up here. And the way I like to do it is I like to rivet this section of the rocket to the av bay. Okay, so there's even a hole for rivets right there. And then shear pins up here. And the idea is that the nose cone is going to come off and pull the main out. The explosion from below will push all of that out. That's a good idea. But I want to have shear pins up here just to make sure that when I shock the rocket with the drogue coming out, which is a big yank on the rocket, I don't inadvertently lose my nose cone and get my main to come out at apogee. So shear pins up here, but that means that it's more than just the volume. You need to break the shear pins as well. And my recommendation then is, if you ever have shear pins that have to be broken for something to work, you should try to test that on the ground. So the way that I would test this particular rocket on the ground is, let me just open it up. I can see that cup right there. So this one happens to be made of PVC instead of the other one was copper. But anyway, so I would place the appropriate charge up here, and then I would run the wires for that charge down into the avionics bay. And I would not set this off using electronics. I would actually set this off manually. Here's how. Let me just put this back together for a moment. When I have the wires that are in the avionics bay, I can actually run them out through holes. And the reason is there always will be holes in the avionics bay. You need to vent the avionics bay anyway. okay, to make sure that things inside of it know the external pressure. So I can run the wires out through holes. And then when the wires are out the side of the rocket, then I can just apply the battery to this wires and make that charge fire. Of course, make sure that the shear pins are in place, make sure that the rivets are in place so that you can be sure that the thing will come apart. In fact, let me show a video of that. So share sound, this is good. Okay, so here is a rocket being tested on the ground. So this is a dual deploy rocket. So the avionics bay is approximately here. This is the upper section, there's the nose cone. And so there's an explosive charge and there are shear pins here which need to break. And let's watch it fire. Oh, there it went. I didn't actually hear it. Got it. Let me do it one more time. I'm going to stop it just when it fires. There it goes. Okay, so the explosion has gone off. Notice that the nose cone has been forcibly pushed out, and you want to make sure it gets pushed out adequately enough that it pulls everything out behind it. So it pulls out the shock cord pulls out the parachute. Of course, the parachute needs to be protected in some sort of a flame protecting cloth. I could see some sparks because of the explosion, which was below the parachute. It turns out this is a little unrealistic because at this point in the flight, the drogue would have already gone off. And so the bottom section of the rocket wouldn't be still together. And it turns out that this explosion was violent enough that it shocked the lower section and pulled it apart slightly as well. Okay, so notice that the lower section just broke as well. That's fine. That would have actually broken in advance on a real flight. Okay. I'm going to do one more thing just for fun. I'm going to go back to this E-match that I don't have any powder. Let's see what it looks like when I spark an E-match. So here's what I propose to people when they are doing an ejection charge test. You have wires. The wires are coming out the side of the rocket. Stand to the side, wear safety goggles, because there's going to be something shooting out the front of the rocket, and possibly the rear of the rocket might go backwards. I'm going to disconnect these. I'm going to pull them apart a little bit. Started, there we go. Okay. So now let's pretend there's no rocket and there's no gunpowder, but let's see what this looks like when I spark it. Here's what I tell my students to do. I tell them, whoever's going to fire it, I say, look, hold the battery in one hand, and with your one hand, hold one wire. There's going to be two wires, one wire to the battery with one hand, and then you can bring the other wire in at your convenience. So here's what I'm going to do. This is going to be a little tricky for me to film. Let's see if I can get this amped under my computer in the view of the camera. Maybe. Maybe not. Well, I'll try to do it. I'll try to do it with two hands. Two hands here. So I'm going to bring in my, I have my battery here. I'm going to bring in my second wire, and let's just watch it spark. Here we go. 3, 2, 1, fire. That was impressive. Okay, good thing I was wearing safety goggles. No black powder, but had there been black powder, the black powder would have ignited and of course caused the explosion large enough to break open a rocket.